Students, in this video I am going to start Taylor's theorem. So what is Taylor's theorem? This is not series, this is Taylor's theorem. Fine. So ये Taylor's theorem है ना कि Taylor's series. So what is the statement? If a function f defined on the closed interval a to a plus h is such that, first condition, the n minus 1th derivative denoted by f n minus 1 in superscript is continuous on the interval closed interval a to a plus h. Second, the nth derivative, here is the n minus 1th derivative, here is the nth derivative. So the nth derivative of function denoted by fn exists on the open interval. Then there exists at least one real number theta in between 0 to 1 such that f of a plus h can be expanded as this: f of a plus h f dash a plus h square by factorial 2 second derivative at a plus h cube by factorial 3 third derivative at a plus and so on, and h raised to the power n minus 1 divided by n minus 1 factorial nth derivative of f at a plus h raised to the power n 1 minus theta raised to the power n minus p divided by p into n minus 1 factorial nth derivative at a plus theta h. So here we have a plus theta h. So statements, and where p is a given positive integer, this p is given positive integer. ठीक, तो सबसे बड़ी इंपॉर्टेंट चीज है फंक्शन का n माइनस 1th डेरिवेटिव is continuous. nth derivative exists, then there exists a real number theta in between this and this such that this expansion holds where p is positive number. Fine. So now we will to prove this, and to prove this we want to use Raleigh's theorem. We want to use Raleigh's theorem. तो Raleigh's के लिए हमें क्या चाहिए? Continuity, differentiability, and a third condition is that function value at left hand point is equal to functional value at the right hand point. ठीक, what is given to you? पहले first given is that a function is given to you whose n minus 1th derivative is continuous. That means जिसका n minus 1th derivative continuous हो, इसका मतलब derivative की बात हो रही है, इसका मतलब by the given hypothesis, so this is the proof, we can say that if function is given to you, then you can easily evaluate its n minus 1th derivative. This is already given to you. So we have f first derivative, second derivative, and n minus 1th derivative, and all these are continuous. So all these are continuous in the closed interval, this, and derivable in the open interval a to a plus h as per the second. So these are continuous, these derivatives are continuous in closed interval and derivable because the nth function, if nth derivative of exists, अगर nth डेरिवेटिव एग्जिस्ट कर रहा है तो उसका मतलब n माइनस 1th भी होगा, n माइनस 2th भी होगा, फर्स्ट भी होगा, एंड सो ऑन. सो सबके सब डेरिवेबल होंगे. सो यही इसमें लिखा गया है. सो दे आर डेरिवेबल इन a to a plus h. सो नाउ जैसे पहले हमने किया था, यू इफ यू रिमेंबर, वी हैव कंस्ट्रक्टेड टू प्रूव द थ्योरम्स. जनरली एनी मीन वैल्यू थ्योरम, जनरली वी कंसिडर अ फंक्शन phi x. Similarly here we have to construct a new function phi x. And obviously this phi x depends upon all these derivatives, so we will take a special form of phi x so that we can easily evaluate the constant a, because here if you will see here what is the a, for example here in Cauchy mean value theorem phi x is fx plus agx. Aim is to find out this a. So here we have selected a special form so that the constant a can be evaluated very easily, ताकि हम बड़ी आसानी से constant a को निकाल सकें. So that's we have selected this a special form of phi x. ठीक, which contains or depends upon these functions f, f dash, second derivative, and so on. And second thing is that we can easily find out the value of constant a. Fine. So this is our phi x. Phi x is this f of x plus a plus h minus x. What is a plus h? A plus h is the last point, right end point. So a plus h minus x, first derivative at x, plus a plus h minus x whole square by factorial 2, second derivative of f, plus and so on, plus a plus h minus x raised to the power n minus 1 divided by n minus 1 at factorial, nth derivative of f at x, plus a plus h minus x raised to the power some p. Fine. So this is a special form. Here we have used all these functions f2, fn minus 1. We have all used f, f1, second derivative, nth minus 1th derivative. So we have used all these terms and this constant is involved. Fine. So now what is unknown here? Unknown is this a. So we want to this a. So here phi is, in this phi a is an unknown. So where a is a constant which is to be determined such that phi at a plus h, which is the right end point, is equal to phi at a, which is the left end point. So that phi satisfies the conditions, all the conditions of Raleigh's theorem, because you will see f, f1, f dash, all these are continuous, already given to you. So that's why this is continuous, this is continuous, this is continuous, this is also continuous, and here this is a polynomial, this is also a continuous function, and hence phi is continuous. Similarly, f is derivable, first derivative is derivable, second derivative will be this f double dash will be derivable, and n minus function is also derivable, because if you differentiate this, so you will get the nth derivative of f, and according to the second condition, nth derivative exists, hence this is also derivable, and this is a polynomial, this is also derivable, hence we can say that phi x is also derivable. And third condition is this, we have already selected, hence Raleigh's theorem is applicable. Fine. So now, so this condition holds. So now what is phi at a plus h? If you put phi at a plus h here, then you will see that here you will have f of a plus h, here you will have this term, due to this factor we will get 0, because x की जगह जब a plus h रखेंगे तो a plus h से a plus h cancel out, hence this term will be 0. This term is also 0 due to this factor, this term is also 0 due to this factor, and hence this term is also 0. So ultimately phi at a plus h is nothing but f of a plus h. That's why here we have f of a plus h is equals to phi at a. So put x is equal to a here, so we get f of a plus, here put x is equal to a is cancel out with a, so we get h f dash a plus here, from here put x is equal to a is cancel out with a, so h square by factorial 2, second derivative at x, a, and so on, plus this term h raised to the power n minus 1 divided by n minus 1 factorial, n minus 1th derivative at a, plus from here a is cancelled out with a, so h raised to the power p into a. So this is given. Fine. So we have this equation, now as f, first derivative and second derivative, n minus 1, these are continuous function in this closed interval, hence phi is also continuous in this closed interval. Second, the function f, second derivative, first derivative, second derivative, n minus 1 and the nth derivative are all derivable in the open interval a to a plus h, and a plus h minus x raised to the power r belongs to n is also derivable in r. This is basically the last term. If you will see this, so this is of this form. So in place of p we have selected r, because we don't know p is any positive real number, so we are selected r is a general number, r की वैल्यू p भी रख सकते हैं, ठीक. So this is also derivable in r, hence we can say that phi x is also derivable in the open interval. Also third condition is satisfied, so we can say that phi satisfies all the conditions of Rolle's theorem, and hence there exists a at least one real number theta in between 0 to 1 such that here we are using the parametric form of Rolle's theorem. Rolle's theorem की दो फॉर्म थी, एक उसकी फर्स्ट फॉर्म और सेकंड में हमने पैरामीटर का इस्तेमाल किया था. सो हियर वी आर यूजिंग द पैरामेट्रिक फॉर्म विच डिपेंड्स अपॉन थीटा. थीटा इज इन बिटवीन 0 एंड 1 सच दैट फाई डैश सी की जगह क्या हो गया है, ए प्लस थीटा एच इज इक्वल टू 0. फाइन. सो दिस इज इक्वल टू 0. बट what is the derivative of x here? If you will see, if you differentiate this function phi dash x, so we get f dash x here, plus from here if you differentiate this you will get minus 1 f dash x. So this f dash x is cancelled out with this. ठीक, if you will see the derivative, then you will see why we have selected this special form, because its derivative is also easy to find out. This here we have f dash x plus, just differentiate this, so we get minus sign, and this function as it is, plus now this function as it is, a plus h minus x, and derivative of this function, so second derivative. Now the derivative of this function, so we get what we will get, plus twice upon factorial 2 a plus h minus x, and derivative of a plus h minus x is minus 1, and second derivative as it is, then plus this function as it is, now the derivative of this, so a plus h minus x whole square by factorial 2, and now the derivative of this will be third derivative, and so on. Fine. Now the derivative of this, we get plus n minus 1 factorial a plus h minus x raised to the power n minus 2 divided by factorial divided by n minus 1 factorial. This is n minus 1, sorry, this n minus 1th derivative x plus now this function as it is and the derivative of this, so a plus h minus x raised to the power n minus 1 divided by n minus 1 factorial and nth derivative of x, and now the derivative of last term, so we get plus ap a plus h minus x ap raised to the power p minus 1 minus 1. So this is the way. Now you will see that this is cancelled out with this, 2 is divided by 2, so this is cancelled out with this, and this term is exactly cancelled out with this. Similarly the second term will be cancelled out, this term is also cancelled out. Ultimately finally we get only this term and this term, all the terms are cancelled out, so phi dash x will be basically this. So here phi dash x will be this second last term and last term, rest of the terms are cancelled out. Now put x is equal to a plus theta h, so f phi dash a plus theta h is equals to here a plus h minus a plus theta h, so h minus theta h raised to the power n minus 1 divided by n minus 1 factorial, nth derivative at a plus theta h minus ap h minus theta h raised to the power p minus 1. But this term is 0 as per the Rolle's theorem conclusion, so this is 0, so this is 0 is equal to, from here you can take h common, so h raised to the power n minus 1 1 minus theta raised to the power n minus 1 divided by n minus 1 factorial, nth derivative of f at a plus theta h minus ap, again you can take h common, h raised to the power p minus 1 1 minus theta raised to the power p minus 1, and from here you can find out a. So a is equal to h raised to the power n minus p 1 minus theta raised to the power n minus p divided by p n minus 1 factorial, nth derivative at a plus theta h, because h is non-zero, theta is non-1. Fine. So this is well defined. Now substitute this value of a in equation number 1. Put this value of a here, put here in equation number 1. So what we will get, no sorry, put this value of a in here, put this value of a in equation number 2. So in equation number 2 we get f of a plus h, f of a plus this plus a, this is our a. Fine. So finally this is the proof of this Taylor's theorem. Now here important thing is that forms of remainder after n terms, we are having its variant depending upon the value of p. p के ऊपर डिपेंड करता है कि हम कौन सी फॉर्म का इस्तेमाल कर रहे हैं, एंड दिस इज कॉल्ड द रिमाइंडर टर्म. रिमेंबर ये जो लास्ट टर्म है इसको हम कहते हैं रिमाइंडर टर्म. सो इक्वेशन नंबर 4, दिस फॉर्म इज कॉल्ड टेलर्स थ्योरम विद शिलोमिल्च एंड रॉची फॉर्म ऑफ रिमाइंडर. इसका जो नाम है वो है शिलोमिल्च एंड रॉची फॉर्म ऑफ रिमाइंडर. ठीक. अब इसके अलग अलग वेरिएंट हैं डिपेंडिंग अपॉन p. p की वैल्यू 1 रखेंगे तो एक फॉर्म एग्जिस्ट करेगी, p की वैल्यू n रखेंगे तो दूसरी फॉर्म एग्जिस्ट करेगी. सो वी हैव इट्स डिफरेंट फॉर्म्स. सो हियर द टर्म, लास्ट टर्म, this last term is denoted by Rn. Rn is called the remainder after nth term. ठीक. तो जो लास्ट टर्म है उसको हम रिमाइंडर टर्म बोलते हैं. Now here there are two forms of remainder. दो तरह के रिमाइंडर हैं. क्या नंबर है? For p is equal to 1, if you put p is equal to 1 here, so Rn will be h raised to the power n 1 minus theta n minus 1 divided by n minus 1 factorial nth derivative at 8 plus theta h. So in place of p we are writing 1. So we get this one. This is called Cauchy form of remainder. तो इसका तब नाम हो जाएगा Cauchy form of remainder. Similarly second one, when p is equal to n, जब p की जगह n रखेंगे तो n minus n will be 0. So 1 minus theta वाला टर्म गायब हो जाएगा. So we will get h raised to the power n nth derivative at a plus theta h divided by n रखेंगे, n into n minus 1 factorial is factorial n. दिस इज कॉल्ड लेग्रांजेस फॉर्म ऑफ रिमाइंडर. ठीक. तो ये दो तरह की फॉर्म एग्जिस्ट करती हैं, कॉची फॉर्म ऑफ रिमाइंडर, लेग्रांजेस फॉर्म ऑफ रिमाइंडर. ठीक. अब मान लिया आपसे कहा जाए कि प्रूफ टेलर्स थ्योरम विद कॉची फॉर्म ऑफ रिमाइंडर, तब हमें क्या करना है? व्हाट वी हैव टू डू? दिस स्टेटमेंट इज ऑलमोस्ट सेम, देयर इज नो चेंज. दिस स्टेटमेंट एंड दिस स्टेटमेंट ऑलमोस्ट सेम except here p, because we need Cauchy form of remainder, and for Cauchy form of remainder p is 1. So just replace this p by 1. So fine. तो इस p की जगह 1 रख दो तो Cauchy form of remainder बनेगा. So we need Cauchy form of remainder. So statement is, if a function f is derivable defined on a to a plus h in such that n minus 1th derivative of f, that means this is continuous in closed interval. Second, the nth derivative exists on the open interval, then there exists at least one real number theta in between 0 and 1 such that f of a plus h is equal to f of a plus h f dash a plus h square by factorial 2 second derivative of f at a and h raised to the power n minus 1 n minus 1th derivative factorial and f nth minus 1 derivative of f at point a plus, here is this is the remainder term. If you remember this term, just replace here. If you remember, this is as it is same, ये पूरा का पूरा सेम है except p की जगह 1 रखो बस यहाँ पर. So just p is equal to 1, we get this h raised to the power n 1 minus theta raised to the power n minus 1. So this is here. Then p is equal to 1 n minus 1th factorial. So 1 into n minus 1th factorial and n. So everything is same except p is equal to 1. When p is equal to 1 we get Cauchy form of remainder. यही हमें प्रूफ करना है. ठीक. तो बाकी का प्रूफ as it is same. Function is this f, f1, f2, f second derivative n minus 1 at the derivative are defined on the and continuous in the closed interval a to a plus h. Hence consider this phi. Phi is equal to f of x plus, as it is same a plus h minus x first derivative of x plus a plus h minus x whole square divided by factorial 2 second derivative at x plus a plus h minus x whole raised to the power n minus 1 divided by n minus 1 factorial f n minus 1th derivative of f at x plus a plus h minus x पहले क्या था p था, यहाँ p की जगह 1 रख दिया अब हमने, ठीक। सो दिस इज, तो एज इट इज सेम है, बस p की जगह 1 रखा है यहाँ. So where a is a constant to be determined such that phi of a is equal to phi of a plus h. अब इसमें वैल्यू पुट करेंगे इसमें, तो पहले हम phi of a plus h की वैल्यू पुट करते हैं यहाँ. सो वही सारी टर्म कैंसिल हो जाएंगी एक्सेप्ट द फर्स्ट टर्म. सो वी गेट f of a plus h इज इक्वल टू phi of a. अब a रखेंगे तो क्या होगा, यहाँ से आएगा f of a, यहाँ से आएगा हमारे पास h f dash a प्लस यहाँ से आएगा h स्क्वायर बाई फैक्टोरियल 2 second derivative of f at a plus and so on. From here we get h raised to the power n minus 1 divided by n minus 1th factorial and nth minus 1th derivative of f at point a plus from here we get a into a, sorry h into a. This now all these functions f first derivative of f second derivative of f n minus 1th derivative of f all are continuous in closed interval. Hence phi is continuous in this closed interval. For all these functions are derivable in the open interval, and a plus h minus x raised to the power r, here r belongs to n, is also derivable. Here we have used r because r is a general term. Here we are having r is equal to 1, but this is the more general term. ठीक, so this is derivable and phi of a is equal to phi of ah as per our assumption. Hence why Rawls theorem is applicable in the closed interval a to a plus h. So there exists a real number theta in 0 to 1 such that phi dash a plus theta h is 0. So now differentiate this. So जैसे वहाँ हुआ था सारी टर्म्स कट जाएंगी, कैंसिल हो जाएंगी, एक्सेप्ट इट्स nth डेरिवेटिव बचेगा, nth वाला डेरिवेटिव. So this term is as it is, its nth derivative will be nth derivative of f at x minus, इसको डिफ्रेंशिएट करेंगे सो वी गेट माइनस ए. बाकी सब टर्म्स कैंसिल हो जाएंगी जस्ट लाइक जैसे ये था. सिमिलरली ऑल दीज टर्म्स विल बी कैंसिल आउट एक्सेप्ट दिस टर्म, सो दिस इज रिटन हियर, फाइन. एंड लास्ट टर्म इज फ्रॉम हियर, द डेरिवेटिव ऑफ दिस इज दिस. नाउ पुट x इज इक्वल टू a plus theta h here, so we get phi dash a plus theta h is equal to, from here we get h minus theta h raised to the power n minus 1 divided by n minus 1 factorial. Nth derivative at a plus theta h minus a is equals to 0. So from here you can find out a, which is h raised to the power n minus 1 minus theta raised to the power n minus 1 divided by n minus 1 factorial, and nth derivative at a plus theta h. Fine. Now substitute this here in second equation, so we get this, and this is our result. This is the result, required result. And last term is basically the remainder term. Remember, this is the remainder term known as Cauchy form of remainder due to this fact. Similarly, if you want Lagrange's form of remainder, Taylor's theorem with Lagrange's form of remainder, then we have to put p is equals to n. So p is equal to n means, so this is the statement. This is the statement of the theorem. We are not proving this. तो मैं इसका सिर्फ हिंट दे रहा हूँ आपको, मैं प्रूफ नहीं कर रहा हूँ. So if a function f is defined in this closed interval is such that the n minus 1th derivative of f, which is denoted by this, is continuous on closed interval a to a plus h. The nth derivative of f is derivable on open interval a to a plus h. Then there exists at least one real number theta in this such that, अब हम क्या करेंगे, here p is equal to n पुट करेंगे. where, here, this is the general proof था जो हमारा, put n is p is equal to n, तो ये टर्म गायब हो जाएगा 1 minus theta वाला, and in place of this n into n minus 1 factorial means factorial n हो जाएगा ये. So this will be here in this Lagrange's form of remainder. We have to prove this. So h raised to the power n divided by factorial n, nth derivative at a plus theta h. ठीक, तो ये कहाँ से आया, ये आया है यहीं से. यहाँ p की जगह n रखेंगे, p is equals to n, so that we get this p is equal to n. This is called Lagrange's form of reminder. ठीक, तो this is the Lagrange's form of reminder. This is the reminder. तो हिंट क्या है इसमें, टेक योर 5x एज, ये एज इट इज सेम सेम, चेंज कहाँ आया, यहाँ पर, हियर a प्लस एच माइनस एक्स रेस टू द पावर p, p की वैल्यू क्या है n. सो ये हो गया हमारा Lagrange's फॉर्म ऑफ रिमाइंडर. बाकी एज इट इज वही है, प्रूफ वही है. 5 ऑफ, ठीक है, 5 हमारा कंटिन्यूस हो जाएगा, डेरिवेबल हो जाएगा, एंड 5 ऑफ a प्लस एच इज इक्वल टू 5 ऑफ a, फिर a की वैल्यू निकाल लेंगे एंड देन फाइनली सब्सटीट्यूट इट हियर एंड देन वी विल गेट द रिजल्ट. ठीक, सो दिस इज द our Taylor's theorem. In the next video we will discuss about the second form of Taylor's theorem and then Maclaurin's theorem. Fine, okay, thank you.